Hi everyone. Today we are going to learn about the correlation and regression. First of all, these are the parametric test, and these are the powerful tools which we have to check few assumptions. Our data should meet these assumptions and fulfill these assumptions. So first of all, our data should be normal. In my previous video I have explained how to get the data normal, and then after getting the data normal we have checked the data reliability and validity. Now it's time to check the correlation. The correlation is used to check the relationship between two or more variables. There are two types of correlation. One is bivariate correlation and the other is partial correlation. Bivariate correlation is used when we want to check the relationship between all the variables, and partial correlation is used when we want to control one variable and to check the relationship between other two variables. So we control the variable in order to see that if there is effect of one variable on the other two variables, so we control, so there will be no effect of that variable on other variables. So the range of correlations is between -1 and +1, and if the value of correlation between two variables is between 0.1, 0.2, 0.3 and 0.4, it is a weak correlation. And if the value is 0.5 and 0.6, it is called medium or moderate correlation. And if the correlation is 0.7, 0.8 and 0.9, it is called strong correlation or high correlation. And if the value is perfect 1, it is called perfect correlation. The correlation can be negative and positive. Thus these signs, negative and positive, shows the direction of the relationship. If the relationship between two independent and dependent variable is positive, it means both the variable will increase or both the variable will decrease. But if the relationship between independent variable and dependent variable is negative, it means that one variable will increase, the other will decrease, and when the other will decrease, the other will increase. Second thing, there are two to three types of bivariate correlation: Pearson correlation, Kendall correlation, and Spearman-Rho correlation. Pearson correlation is used when data is normal, and Spearman-Rho correlation is used when data is not normal. So all the values of the Pearson correlation, Kendall and Spearman-Rho correlation is between -1 and +1. So we are going to check the relationship between job satisfaction, turnover intention and cognitive style. So you have to go to analyze and then correlate. You see the bivariate correlation and partial. We are going for bivariate. Bring your variables like satisfaction, colleagues, supervisor, job security, work at company or work environment, salary and work. I think I have recorded the variable work, maybe. Yes, this one recorded one. And we have total job satisfaction, total turnover intention. This is the Pearson correlation and total correlation, and click OK. This first column is the relationship between satisfaction and colleagues, satisfaction and supervisor, satisfaction and job security, work at company, salary and work, total job satisfaction and total turnover intention. If you see that all the relationship between satisfaction and colleague, satisfaction and supervisor are moderate, this double star means that this is highly significant at 0.000. If there is 1 star, then it will be significant at 0.05 level. The relationship between satisfaction and colleagues is 0.364, weak but highly significant. Work and company is weak but significant. Salary weak and significant but positive. but satisfaction with work is negative and insignificant, and satisfaction with job satisfaction is high and significant, and relationship between satisfaction and turnover is minus 0.283 and highly significant. This means that when the satisfaction will increase, the turnover intention will decrease, and when there will be a decrease in satisfaction, the turnover will increase. In the same way, the relationship between colleagues and supervisor is moderate, significant, job security is significant, work in a company is significant, sale is significant, but with work it is insignificant and negative. With job satisfaction is moderate, and with turnover intention is negative. So in this way we have to check the relationship, and if you see the diagonal in this in this table, this diagonal 1 means that the satisfaction variable is perfectly correlated with itself, and the same way the colleague variable is perfectly correlated with itself, and so on. So this is the relationship to check, to accept and reject the hypothesis, to check the relationship between the variables. This correlation is used. Now we are going to check to run the regression analysis. We have to go to analyze and then click on regression and linear regression. Okay, so in this box you have to add the variables. You have to develop a regression equation, and as you see, if there is a dependent variable box and independent variable box. In independent variable box we have to bring independent variables. We have 7 independent variables like this one, this recorded work, and we have a dependent variable total turnover intention here. Now there are 3 types of regression: simple linear regression, or you can say multiple regression, stepwise regression, and hierarchical multiple regression. If you use one dependent variable and one independent variable, then it is called simple linear regression. But when you use more than one independent variable, like I have used 7 variables as an independent and 1 variable as a dependent, this is multiple regression. So if you see here, method is enter is chosen. So if I select stepwise, then it will be stepwise multiple regression. So the variables which have insignificant effect, beta effect, on the dependent variable, then the regression will discard or exclude those insignificant variables and will kept those significant variable. But if we use enter, it will kept all significant and insignificant variables with itself. Third is hierarchical multiple regression. Hierarchical multiple regression is used in mediation and moderation, or when a new variable is introduced. So when we will use the moderation and mediation, we will use hierarchical multiple regression. We have to check the R-square change, and if you see this box next, if you click on the next and enter the another independent variable, then it will be hierarchical multiple regression. But in this case we are just going for the simple multiple regression, and go to statistics, and we don't need Oscar chain, we need multicollinearity diagnostic. You can check Durbin-Watson plots. This is heteroscedasticity, Z residuals, Z predictors. Continue. If you want to save any Mahalanobis value, Cook's value, leverage, or any other thing, but we don't need here, and continue. Okay, the output is here. This is the correlation R, 0.5 to 1 of independent variables with dependent variable. This is R square. It means this R square is called coefficient of determination and variance. It shows variance. These 7 independent variables are showing 0.271, means 27.1% variance upon total turnover intention. So here this F value shows the model fitness. This value ranges between 0 and infinity, and it is significant. It means that our model is fit, and this R square value should be between 0 and 1. So it is 27.1. If you divide this regression value, this one with this one, it will give you R square. Third, we have to check the coefficients. This is the beta value. This beta value shows and these significant values. If you change, if you can see that the beta value of satisfaction is 0.070 and significant is 0.215, it means that 1% change in satisfaction will bring 0.07 or 7% change in turnover intention, and colleagues value here is 0.002 and insignificant 0.973. Supervisor is minus 0.160 and significant. It means that 1% change in supervisor will bring 1% change in supervisor subordinate relationship will bring 16% change in turnover intention. If the relationship between supervisor and colleagues are good, then the turnover will reduce to 16% and it is significant. The job security is insignificant, work and company is significant. It means that if 1% change, if a company brings 1% change in work and company, then it will reduce 24.8% turnover intention and it is highly significant. Salary, if the company bring 1% change in salary, then it will reduce 26.4% turnover intention. It is highly significant, and same with the work. It is also significant. Okay, now the point which in this model beta values are given, which is the most dominant factor among all the independent variables. We have 1, 2, 3, 4, 5, 6, 7. We have 7 variables. So which variable is the most dominant? If you see, it is 7%, 0.2%, 16%, 8.8%, 24%, 26.4%, 10.2%. So this salary is the most dominant factor among our model, and it is highly significant. So you can add one more objective or hypothesis in your study to identify the most dominant factor among the model. So this is the multiple regression. Okay, now we are going to run the same model. You have to go to analyze and regression and linear, and we have to check the stepwise regression and click on OK. If you see, this is the model summary. This is the first model, R square. This is the second model, third model, fourth model. 17.5%, 23.9%, 25.6%, and 26.4%. And model is fit in the ANOVA. In the ANOVA table, F value is 0 to infinity, 0 to infinity, and significant. All the models, 4 models are fit. In this coefficients, if you see that the first model is highly significant, work at company, and its beta value is 40 minus 0.419 means 41.9%. If 1% change in work and company can reduce 41.9% change in turnover intention. In the same way, work at company and salary is also significant. Work at company salary and supervisors are also significant. And work at company's salary, supervisor and work are also significant. But if you see colleagues, supervisor, these variables are excluded from the coefficients from the coefficient table because these were insignificant. If you see the excluded variables, you can see this colleague, supervisor, job security. They were insignificant. That's why they were excluded variables. And there is a collinearity diagnostic, residual statistics, and this is the heteroscedasticity. So if you can see that almost all the responses are gathered at one place, it means there is no heteroscedasticity problem. If there is a problem of heteroscedasticity, then you can install the Ahmad Daryanto heteroscedasticity application in SPSS, and you can run the regression in Ahmad Daryanto file, and you can see it will solve your heteroscedasticity problem, and also it will give you the Bruch-Pagan test value. So that's all. Thanks for watching. For mediation and moderation, watch our next video.